Hello everyone, welcome to our new CL tutorial. In this tutorial we are going to analyze BJT problems. As I promised you, here's a new video. So, there are three types of BJT problems, and this is the first type, and it's called fixed. Okay, so this is called fixed. In this case, you have to redraw in order to solve this problem. Okay, so I will draw in this way. Here we will have voltage source, here resistor, here this 3 node, okay, this 3 node, given 3 node, and now here resistor, here nothing, voltage source, yeah. So this is how you redraw the fixed one. Okay, here the voltage source, you put the voltage source that you're given, this one. In this case it's 16, and here is also 16 volts. Okay, this is just R1, here it's R1. Okay, so what you put here is the only resistor. You're given this one, so you put here this one, 50K. Okay, here you have your VB, okay, this one, and this is, as you have understood, this case RS, it's called RS, this is called R1. Okay, so 1.8 K ohms. In this case you have VC, here you have actually VE. So now here voltage source is VCE, and also here there's a voltage source connecting this VB and VE. Okay, I hope you got it. So now we have here what? VBE. Okay, so the very first thing that you do is to find out here IB, because here you have the current flowing this direction. Okay, this direction, this is IB. So once you have found IB, then you find IC. IC flows in this direction. Okay, this is IC. Okay, so as you see that IB is coming in this direction, IC is coming in this direction, so they meet here. So now here in this direction they form what? IE. Okay, in fact the IC equals to B at theta multiplied IB, and IE equals to IC plus IB. So we can denote the value for IE. This is going to be IB plus multiplied in the brackets theta plus 1. Okay, it's pretty simple. Okay, so firstly you have to find this IB, and you find the IB just considering this part. Okay, so when you make KVL, let me redraw this here. Okay, plus minus. We have here also just a voltage source. Let's say this here we have VB, right? As you can see here VB, so let's say VBE, actually VBE, and here we have nothing, so just connect it. So here IB, you make KVL, so you make this R1. Actually this R1 is going to be what? IB multiplied just resistor is 51K ohm, and then plus, yeah, you make this plus VBE. VBE's value is always 0.7. okay, just remember VBE in any case, in fixed, in each case, here you have just plus minus VBE, and its value is always 0.7. okay, so plus 0.7 VBE, and here you made this minus, so minus 16 equals 0. So overall, as you see here, actually, yeah, here, then now actually this was, so let me, yeah, this was here, but professor moved it here. So now as you can see, we have 16, we moved this side, 0.7 also moves this side, and we divide everything by this value, and finally we get IB's value. So now I've told you that you have to memorize this formula. This is here, then you easily find this IC. So your objective is actually to find these values, okay? But anyway, the process is the same. You always consider the same stuffs. I mean, in any case, in fixed or in any case of BJT problems, firstly you find IB from the left side, okay? Let me write it here. Find IB from the left mesh, okay? This is mesh. Then find IC and IE from formula. I've given this formula, right? This and the source tabs is also easy. Just find, I don't know, any asked value from the right mesh. Do KVL in the right mesh, and you will get what you want. I mean, for example, you ask it to find the voltage here, or for example VC. For this case, you do KVL here. So in order to do KVL, you need the value of IE, IC, right? IC, right? So you find the value of IC, IB from the IB. So firstly, logically, you find IB from here. So just this is algorithm, okay? So now we find IC, and then we can find VC. I mean, we can find what? VCE. Okay, this is search it. So in order to find VCE, we consider this in the right side. I mean, in the right side of the mesh. I am writing this. I'm writing this everything as one voltage source. Here we have VCE. Okay, as you can see, this is VCE. So now here I have this RC, this was 1.8 k ohm. Here I have plus minus 16, right? And here I have nothing. So you should find just VCE, right? And do you know that there is a current IC, okay? So that's easy. You know the IC, you have calculated IC by the formula using just IB's value. So IC is this one. So you do KVL, okay? Current flows in this direction, also KVL in this direction. So you made this one, this is plus minus because the current, goes out from plus and should enter the same polarity, plus. So it's plus, that means 1.8 k ohm multiplied IC and plus, okay? Actually, instead of IC, let me write here just the value of IC. So this is milliamperes. So plus, and then what? VCE is not given. We have to find this, okay? So then we made this minus 16. So it equals 0. So overall, as you can see, VCE's value is going to be 7.52. You see, this is here. So that's it. Actually, then you have to find VB, VBE, and the rest of stuff, I think, is easy. Let's consider these cases because, mostly, just mostly, the very difficult stuff, actually relatively difficult stuff, is to find out this VCE, because for this you need the value of IC you got from IB, okay? So for IC, IC's value, you need to find VCE or any stuff. So have to find just VC's value. There's a question, right? So be really careful. So as you can see here, there is nothing right here. So that means this is ground 0. So ground 0 goes up, there is nothing, there is also nothing, right? In this branch there is nothing. So we have but here VE. So if there's nothing, VE's value is 0, right? Let me read it off here. So you have this 3 node, and you have this ground 0 voltage, and there is something, there is something, but we're interested in this branch, okay? So in this branch there is nothing. Nothing means in each point the voltage is 0. So VE is 0. So here VCE, okay? Here VC, you know what? The current goes in this, in this direction. So VCE's value is minus of VC minus VE, right? Because it goes from here to this potential VC VE. So VC's value is the value of the result of this one. So we know VC. We don't know VC, but we know VCE. I mean, VCE equals to VC minus VE, right? So we know this one. So VC, we also know this one. It's equals to 0, right? Yeah, it's equals to 0. That means VC is equals to VCE. So it is what? It is this stuff. And actually this is 4. And how to find the value of VB, okay? So as I've told you, here again, let's draw it. Here we have, let's say, VB, right? And here this is 3 0. Here VE. Here we have VBE, and if you remember, I've told you that VBE's value is always 0.7. So as you know that VBE, I mean this is VBE, so that means VB's value is minus result of VB and VE. So it equals to VB minus VE. So you know that VE equals to 0. So in this case, VB is equals to 0.7. So let me pause this video. And not pause, just stop this video, and next day, tomorrow, I will try to make a video for other cases, but just please study them on your own. The relatively is everything is the same, so this is a practice, just this is fixed. So try to solve this one. Next time I will analyze it, because fix it because there's only this RB. For example, this is also fixed. It's also fixed. There's a task for you to solve these 2 exercises, although there's solution is given. Okay, this one is not fixed, and this one is emitter. Emitter, what does it mean? If you remember, after here, I mean this branch, we didn't have anything. Our VE was 0, right? In emitter we have here a resistor. Here we have resistor, so everything is still the same. Here there's only 1 resistor, but now here also resistor. Okay, in emitter there, I mean in fixed there was no resistor, but in emitter there is, so that's why it's emitter. We're gonna analyze this in the next tutorial. Thank you very much for your attention. Solve problems, please. 2 problems, okay?